Hi folks, welcome back. I hope you're all doing well. So today I want to take a look at a paper where the authors want to quantify with a benchmark how truthful or how factual the answers given by a large language model like GPT-3 are. Now, of course, there's been a lot of excitement around these large language models, and people have been using them for a wide variety of experiments and applications. But if you really want to use them in serious applications, you need some measure of how correct or how factual the answers given by these models are. And that's really what the authors are trying to get at. And to do that, they're constructing a particularly difficult test. The authors make up a benchmark of questions. They have about 800 questions. And these are designed to test what they call imitative falsehoods. These are widely held misconceptions that the model may have learned from its input text. And they're trying to see if the model is good enough or smart enough to not fall for the trap. And just as motivation, as you can see in this table, they have a bunch of questions and the answer from GPT-3. And you can see in all of these instances, the answer given by GPT-3 is factually incorrect. They have a GitHub where they have all these questions and answers as a CSV file. I'll link it down in the description below. And as you can see over here, they have this giant CSV file with all the questions and answers. If I scroll over to the right, you can see what the correct answers are going to be. And these questions span a number of categories. So that's their first contribution, to actually compile a benchmark of questions and answers that can be used to test the truthfulness or correctness of a large language model. Their second big contribution is to establish a baseline. And what they found was the best performing model, which is GPT-3 with 175 billion parameters, was truthful on about 58% of the questions, while human performance was around 94%. The answers given by the model are judged along two dimensions. One, of course, is correctness, whether the answer is true or false. And the other one is what they call informativeness, which is essentially a measure of how detailed the answer was. So, for example, the answer could be really simple, like no comment, but it could be correct, but it wouldn't be very informative. So more detailed answers are ranked as more informative. One of the more surprising findings of this work is that larger models tend to be less truthful. As you can see in this diagram over here, just on GPT-3, as you scale up the number of parameters, the percentage of true answers on this benchmark steadily decreases. They call this inverse scaling because as the model gets larger, you don't see more truthfulness. They hypothesize that this is happening because the larger models are better at learning the training distribution, and so they fall for imitative falsehoods more often. The answers generated by the models are scored by humans, and human evaluation is used to judge both the truthfulness and the informativeness of the answers. Now, in general, since using humans for evaluation is pretty costly and time-consuming, they also tried to construct another model, which they call GPT Judge, to classify the answers generated by GPT-3 as true or not. And this was done by constructing a training set which consists of tuples of question, answer, and label, where label tells you whether the answer is correct or not. Now, since the authors found this inverse scaling effect, they're saying that scaling to larger and larger models is probably not going to help scores on this benchmark. What they did find was that you can use other techniques such as better tuning or engineering of the prompts. They saw that if you construct the prompts in a way that asks GPT-3 to be more truthful, that improves the truthfulness score across this benchmark. And here are a few concrete examples of that. You can frame the prompt in a way that's helpful or in a way that's harmful. For example, you can frame the question like a conspiracy theorist. Here are a couple of examples that show how a helpful prompt can be framed versus how a harmful prompt can be framed. And they found that when you frame the prompt in a more helpful way, you get more truthful answers. Victor. So to wrap up, the authors here are trying to quantify how truthful large language models like GPT-3 are, and to do that, they have constructed a difficult benchmark of about 800 questions, and then they measure the correctness of the answers on those questions to quantify how various large language models do. They found some surprising effects like inverse scaling, and overall they point out that currently large language models are much less truthful than humans, so there's still a lot of work to be done here. I hope you found that helpful, and I will see you next time. Thank you very much.